Hi, this is an ArcGIS Runtime SDK presentation, building a routing application. I'm Frank Kish. I'm a PE on the network analyst team, and this is Konstantin. He is a developer on the network analyst team. I'm going to go over a number of things. First, we're going to talk about what goes into a routing application. We'll talk a little bit about data. We'll do a demonstration about creating a mobile map package. Then we'll look at the Runtime API. We'll look at some demo code, and then we'll talk a little bit about resources and the road ahead. The slides and code and data are all available, or will be after Dev Summit. So the proceedings.esri.com is where you get the slides, and I have a shared folder that I'll put the code and data, and probably actually the slides too, afterwards. If you need to write this down, this is the last slide of the presentation also. So, so what makes up a routing application? Usually you need a map of some sort for visualization. And that can be from a service or from a mobile map package, which is something we'll talk about a little bit later on, if you're not familiar with that. Usually you have some sort of search capability. So you might be given an address and you need to get the XY location of that, or you might have an XY and you want the address at that location. And to work with that, we have something called the Locator task. And then for routing, you might want to find the path between a number of points going from A to B to C, or potentially you have a number of points and you just want to find the best path between those points. For that, we have something called the route task. Where's this all available? This is all available actually at a license level, the light license level. That's for viewing and packages, viewing services and packages, routing, and place finding. So one of the first things you usually have to ask yourself, are your users usually connected, or always connected? And if so, you can use services for most of the needs to do mapping and routing and geocoding. So for example, you could use ArcGIS.com, and we have mapping services. We have world geocoding services, and we have routing services. Potentially, you could set up your own portal and server combination where you publish your own mapping services and geocoding and routing services. But if your data, or if your users are frequently disconnected, you want the data on the device. And if you're in this situation, you would create something called a mobile map package, and you would use ArcGIS Pro's Create Mobile Map Package tool to do that. And what that creates is a single file that can contain multiple maps, locators, and network data sets that you can use within the Runtime SDK. Alternatively, you could use a hybrid approach where you have maps coming from, let's say, your mobile map package, but you want to use ArcGIS.com for searching and routing because you don't have, let's say, a locator or a network data set. Or potentially you don't have base data and you want to use ArcGIS.com for that, and but you have your own search and routing services that you're going to use. So you can have a hybrid approach. In the end, if you're disconnected or connected, there's very little difference when you're doing this stuff programmatically. It's really about the initial creation of the map or the task. So for example, if you're creating a route task, it's a matter of whether you're pointing to a URL or if you're pointing to a mobile map package and the network data set that's in there. It's really about what your resources are and the workflows that you need to support. So you've probably all used services before, but maybe you haven't actually created some local data. To create an address locator is fairly simple if you have some data that you need to use as to locate on. In this example, I have a screenshot here of creating a single field locator. I used these fire hydrants as my data source. It had a name field that I was going to search on, and I enabled suggestions so that I can use that within our API. What this created was locator files on the disk, and then we're going to include those in a package. So let's just go PowerPoint for a second and take a quick look at Pro and the Create Mobile Map Package tool. So first of all, let's just look at this map a little bit in this project. I have a base map that I created that has some base layers, and it also has a network data set in here. It's this streets_ND. From this, I also created a map that has some of my operational type layers. So my fire hydrants, that's the one I create the locator from, and a couple of stops feature classes that we're going to use later on in this demonstration. And then I included that base map in this regular map. So to create a mobile map package, we have a tool called Create Mobile Map Package. You can search on that. When it first loads, the active map is the first input map. You can put other maps in here, so you can have multiple maps in a package. You don't always do that. It really depends upon your use cases. The output file is wherever you're going to create this, so whatever name you want to use. The locator, in this particular case, you could go out and point to location files on your disk. Since I had created a locator in this project earlier, it's actually already referenced, so I can just use the drop down. Your area of interest could come from that's the area that you're going to be extracting and packaging. You can set this to specific polygon feature classes, or you can use this extent drop down and get it from a variety of sources in the map already. We'll just use current extent. You can clip the features so that you have straight lines. Otherwise, you're gonna on the edges. Otherwise, it's gonna bleed off a bit. Depends what you need. And then the last bit of this are all metadata items. They can get used either when you're showing this package to a user in an application, or when you load it online. ArcGIS.com will show the values in here as metadata. We'll just run this. One thing to note, though, while we're doing this, and we'll look at this a little bit later on in the demonstration, is that the network data set is actually a part of the map, whereas when we created the package, the locator is actually part of the package. I only point that out because within the API it just matters, depends upon where you're actually getting the instantiating those objects from. We can let this run in the background. We'll go back to the slides for a second. So a few things to talk about when making this mobile map package. Operational data and base map data have to come from different geodatabases. This is because operational data you could actually be editing, whereas base map data, what happens in this process is that it gets compressed, and just to have a smaller footprint when you load this data onto a device. But what that means is it's non-editable. So they have different properties. For routing purposes, you really want to take a slightly larger area. And the only reason for this is if you're doing some routing near the edges, you want to ensure that the connectivity that a user is going to want to have if they're routing near those edges, that they could go outside the boundaries of maybe your map or of your study area at least, so that they can maintain that network connectivity and have a good route. And one other thing is that all this data gets projected when you create the mobile map package to the map spatial reference. So if you're intending to use this data for analysis purposes and the spatial reference is something that's important to you, you have to think about that when you're creating the mobile map package. So let's talk about the API and the SDK a little bit. So as you probably know, we have multiple platforms that we support and languages: Android, iOS, Java. So if we look at the code that we have in our SDK, what we try to do is across those platforms is maintain a consistent API. So if we were looking at how to load a map package in .NET, in particular C# in this example, we can create a mobile map package by opening it from a file path that I've defined. And then I set the map to the first map in this mobile map package. Like I said, you can have multiple maps in a map package, but you should always have at least one. If we look at something like this in Android, Java, again, we just create a mobile map package. We have a path to the file, we load, and then we set the map to the first map in the package. And then if we were to use Swift, again, create a mobile map package, path to the file, load, and set the the map to the first map in the package. So the APIs are somewhat consistent, changed a little bit for each of their languages, but in general, what you do is exactly the same across the platforms. Now let's talk a little bit more about routing itself. So your basic steps for routing is you instantiate a route task, you create routing parameters and you set some properties on those, then you solve, and that's when you find the routes. So you just really have kind of basically 3 steps. Well, let's talk about the route task and route parameters object. The route task gets created either from a network data set that lives in your mobile map package, or you can point to a URL for a service. And the routing parameters, that's an object that's going to hold all the inputs for a solve operation. So you pass that back into the route task to solve. In particular, you want to set stops on it. You always need at least 2 stops to do a routing, but you also have some other values that you can set on the route parameters, like if you have a start time. If you want to optimize the stops, you can set the find S sequence. You can preserve first and last. So these are all properties of the route parameters. Looking at this in code, we have a route task that we create. And in this particular case, we are pointing to the transportation network, the first one in the map. We create the default parameters. We set stops from a list of stops, and then we solve using those route parameters. The same basic steps hold true if you were working in Java. So you create a new route task, and in this particular case, we're pointing to a service. You create the default parameters, you set some values on it, you solve passing in the route parameters. They're pretty much the same. So let's escape out of here for a second and take a little bit of look at this in some code. Is that legible? Is that better? Okay. Let's see. Well, here, let's just start this application quickly once. So on load, it's loading up a mobile map package that I created earlier today, similar to the one that we created in this session. We can also switch over to a map service and switch back to our mobile map package. We can also do some simple routing. This is what we'll go through first. So all I'm going to do is just drop a couple of points and do a solve. So that gives me back the line between those 2 points. So if we look at the actual code that's running here, so you're probably all familiar with setting the loading from a service. In this particular case, we're using the shortcut to get the streets from ArcGIS, the streets base map from ArcGIS.com, and that's when we were using the service. If we wanted to load from a mobile map package, in this particular case, I've put it in an app data folder that's living in the same location as this application. But in general, as I showed you before, we just create a mobile map package. We open that from the path, just making sure that there's maps in here, and then eventually setting the the map on this map view to the first map in the map package. Fairly simple. So when we're creating a route task, as I said before, and I showed you, we create we take the transportation network from the map. It was, as I showed when we were looking at creating the mobile map package, I know that the map is, or sorry, the transportation network was a property of the map. It lived in the map, so that's how we have to acquire it here when we pass it into our route task to create our local route task from this network data set. One thing to note here is that since the transportation network is a part of the map, you have to make sure that the map is loaded. So I check here the status of the map and ensure that it's loaded so that I can get to the transportation network. Otherwise, you won't be able to acquire the transportation network and create the task. So you have to wait. So if we go back to the very beginning where I was loading this, I also set the map load status. In here, I also create the mobile map package, or I create the local route task when I initially load this map. So we don't necessarily, so we have to make sure the map is loaded when we're creating this task if we're using local data. Let's see. Oh, wait, sorry. If we're creating it from a service, one of the things you have to think about is the service might actually be, the service might actually have security set on it. So in this particular case, I'm doing standard authentication through my portal to get this token. To get this token, then once I have this token, I can pass it into my route task create async down here to create the actual route task from this service. Now, one of the other things I'm passing in here is a URL. So you could pass in an actual HTTP string to that URL, but in this particular case, I have a portal item. And one of the things portals can have are default services. They can have default routing services, default locating services, but they don't have to have one. So that might not be set. But in our particular case, the portal I hit, we do have a default routing service. So I use these helper methods on the portal item to get the default routing service. So this URL, what this URL actually, where this method actually passes back in my particular case, is we're pointing to the world geocoding service as our default routing service. So I talked a little bit before about creating route parameters. So I have my route task, and I create default route parameters. Those route parameters then get set or get used later on, but I have to set stops on them. So in this particular case, I'm setting stops from the graphics on my map. I'm creating stop objects, and then I'm setting them. I solve, passing in those route parameters, and then what I get back is a route result. And in this particular case, I just loop through the route results, and I actually just draw graphics on the map. So if we just go back to a quick demo, this is when I drop features on the map, and I solved. So I'm just drawing the polyline that comes back. This is like the simplest example you could have. We go back to the PowerPoint presentation. Sorry. Oops. Sorry. Sorry about that. Okay, so let's look at let's look at routing a little bit more in detail. So one of the things that network data sets can have are travel modes. And travel modes are a collection of properties that define how the vehicle can move through the network. One of the main properties of that is the impedance, and that's the cost attribute you're going to minimize when you're trying to find a path. And also there's restrictions. Restrictions are things that either what a vehicle is allowed or not allowed to do to move through the network. These are defined within the network data set itself. And they're a collection of properties that work together. I bring this up partially just because although our API allows you to change little bits and pieces of a travel mode when you write an application, you have to, the person who's doing that change has to really understand how that collection of properties are going to work together. If you change something that you're not expecting to have an effect on your overall route, you might come back with an unexpected result. What you really should do if a user needs to change or have a different travel mode properties, is that you should create a new travel mode for that particular situation, test it, make sure the outputs are as you expect, and give them a data set with that particular travel mode that they can use. One other thing is about routing services. To create a routing service, you publish a route analysis layer. That sits on top of your network data set. And what that means, though, is that the network analysis layer can have more properties than the analysis layer can have more properties than your network data set. So in a service, you could set a start time, or you could set that reordering stops to an optimal route is allowed by default. So if you're hitting one service, you might get certain properties, but if you're hitting another service, those properties could be slightly different. So you really have to know the service definition. Within the ArcGIS runtime, we have a number of routing classes. We've already talked about the route task and route parameters a bit, but we also have a number of other properties like route Taskinfo and stops and direction maneuvers. So we're going to look at those a little bit more in detail. So the route Taskinfo, what that does is it exposes the underlying properties of the network data set or service. These are read-only properties, and what you use them for is you would use it to create a default or a UI to show what the defaults of your particular service are, and give the user options, valid options that they can change to call the solve operation. So what it allows you to do is to correctly set the route parameter values. So you could have something like you can get back your travel modes that exist in the network data set, or the valid cost attributes of the network data set. And it allows you to present those to the user so you know they're valid for this particular network.
I have a question.
Sure.
These are from, the screenshots are from ArcMap, right?
No.
They're not?
These ones are actually probably from ArcMap.
Yeah.
These ones?
Yeah.
You're using them as a reference because they happen to have all the same settings.
Well, I use them because the layer the layer properties, right now you can only publish the analysis layer from ArcMap.
Well, you can only do that from ArcMap.
Publish to the service, to server.
But the
packaging happens in Pro. Yeah, I just kept the two UIs consistent. One other thing that we have in the runtime is a stop object. This takes a map point to create a stop object, and that map point can have a different spatial reference from the network. Once you solve, we actually project those map points to the spatial reference of the network, so they don't have to be in the same coordinate system. Stops also have properties. You can add costs to that property. So if for some reason when you get to a particular location, you know it's going to take you an extra 10 minutes there to drop something off, you can add that cost to that stop when you're creating the stop object. Or if you have time windows, you can set time windows on your stops, and that allows them, the solve, to use those time windows to calculate the proper route. Stops also can come from a table, either an online table or a local geodatabase that you can read. And the field values on those tables then get mapped to individual stop properties that's based upon a naming convention. Not going to go into it here, but there's a link in a help document that will help you look at what those naming conventions are. So once you've created your route parameters object, you solve. The solve returns a route result, and one of the things that's part of that route result are messages. And this is like high-level information about how the solve happened. Something like, how the stops were located on the particular network elements. And you also get back routes. And those routes can have multiple properties on them. It has distance, travel time, and total time. Those two differ with the fact that the total time can include waiting time based upon the costs that you've set up. And the stops, you can return stops. They can be part of the route. These stops are the located stops. They're slightly different, and they're copies of the input stops. And they differ partially because they've been now snapped to the network. So their XY location can be shifted because the stop has to be on the network. And then it also has other properties. The stop objects have read-only properties that get populated by the solve operation, such as location status. And then finally, you also have directions, direction maneuvers in particular. What you get there is a number of properties. You get direction text, and that's something you might want to show the user. You also have geometry, so each direction object that comes back in a list has an associate geometry with it. It has a maneuver type, so that might be start or stop or turn. And then those are even broken down further into maneuver messages. So these are other smaller bits of information that you could present to the user. And then you might, depending upon your network data set, you might also have direction events. So something like crossing a state boundary or a time zone. You can get that back, and if you want to, you could present that to the user. So let's look at some of this in an application. So we had that simple application before where we dropped a couple stops. But now I'm going to go in and actually drop a few more stops, and we're going to solve. And now what we're getting back, I'm populating a whole bunch of other information. So as I said, we have messages. In this particular case, I don't have any messages that came back from this solve. But we also have some other information. I get the total length. So this is coming back based upon our solve. We get the total time and the travel time and the total time. In this particular case, they're the same because I didn't have any wait time set up. I've also accumulated costs. So in your network data set, you can have costs. When I did the solve in this particular case, I asked it to accumulate all the costs that are defined within this network data set. And then my stops that have come back, I have some more information. So I dropped 3 stops, and as I said before, some of these are populated by the solve operation. In particular here, I have the location status. It's been dropped on the closest element. I also have the sequence, which one came first. And then if we look at the directions that came back, I've set them up in this little list view. And they have, as I said, they have a geometry property. So we can zoom in and out based upon the actual individual direction elements. Let's see. If we look at the code, let's see. Similar to as before, I have my route task object. I create default parameters, but in this particular case, I'm going to set some stuff from the UI. If I look at the code here. I'm taking the, I have a checkbox that I'm using to set the best sequence if I wanted to have a different sequence based upon what the stops I've passed in. I have checkboxes for preserve first and last stop. And then I also have set up travel mode radio buttons. So depending upon which one's selected, I also use the travel mode property to set that on the route parameter. And then I've also told it to return my stops, told it to return my directions. And as I said before, I accumulate the cost attributes. I use the route Taskinfo object that tells me about the network data set and get the cost attributes back that are valid for this network, and then I tell it to accumulate each of those. Then eventually I solve. Once I solve, I get those, I process the route results. So if we look at what that looks like, a lot of this is just a lot of the text that came out. So I'm looking to see if there's any messages. If I didn't have any messages, I just give it a generic no messages. I then walk through each of the routes that came back in that route tab or that route result object. I draw the poly line, associate with that, and then I start looking at the information that came back. So did it have a route name? If not, I just create a dummy route name here based upon numbering. Then I get back from the route result the total length, travel time, and the total time. To get the units, I look at the cost attribute or the time and distance attributes based upon what is being used for this particular travel mode. And then I go back to those accumulate costs that I want to show to the user, and I again use the route Taskinfo object to walk through the costs and get those costs off the route that that was returned. As I said before, we also return the stops. So I also draw those stops on this map, so that's where we see them shifted slightly, and then I get information about that, and I show it to the user based upon each of those stop objects. And then eventually I get into the directions, and the directions actually have a fair bit of information, but this is where I was setting up the route Taskinfo, or sorry, I was setting up the list view of the directions, and I'm bringing together the maneuver type, the direction, and setting that up within that grid view. I also write a bunch of this other information that kind of gets overwhelming to a file. So as I said before, we have direction maneuvers, but we also have these other parts that, such as this is the text I showed, but we also have other properties. Once we get down to the direction messages, we get these smaller bits of information like summary and length that you could provide to the user depending upon what you're trying to show them. Let's see. As I said before, you can also use the, you can get stops from a table. When we looked at this, this project that we created, this map that we created, this mobile map package from, we have these two stop feature classes. If we open these up and look at the data in there, in this particular case, I just have some name properties, and those will get mapped to the name of the stop when I do a solve. So if we go back to this particular one, I solve using the values from this particular table. So I've pulled the stops out of that table and I've solved. Now I'm only using two solves, or two of these stops, because if we go back and look at this code, one of the things that we do is when we pass in a feature table to set the stops, we can also pass in a query parameters. And I've defined the where clause for that query parameter up here. So I've set it to use only stop 1 and stop 2. So if we go back to our map, we have stop 1 and we have stop 2, and those are the only ones that I'm using in this particular case. So I'm not using all the data from this particular table. Similarly, if I solve, I can also solve based upon a second way, and we'll look at the code. But in this particular case, we've got 2 routes back and a number of other properties. These are the return stops in this. These are the return stops in this particular case. In this case, we got a route name, we got the stop name back. Sequence and location as before, but we also got a time window set. So if we go back to our original data, we'll see that in this case I'm using this data set, and these properties are being mapped to your stop feature class, or to your stop object. So I'm getting the time window, I'm getting the route name, and I'm getting the stop name. So as I said before, if you use a table, the properties on those values based upon naming convention can, the fields on these tables can be used as properties on the stop object. If we look one more time at the actual code here, in this particular case, that was the second example. I'm using the stops extra just meaning they have extra fields on it. And in this case, I'm using a query parameter with where clause of 1 equals 1. All that tells you is that you want to use all the data in this particular data set. And then we're passing this query parameter into the set stops of our route parameters and our feature table.
There is a question.
Yes?
I just wanted to ask, is it possible to have the travel code be something that's determined from the UI?
Oh, well, yes. I mean, if we look at the, in this particular case, I've got 2 travel modes that I'm reading from the underlying network data set that I've used. So if I switch over this service, takes a second to read it the first time. It's reading the travel modes from that particular network service now. So if I set drive time and I solve, I get back my total length and total time based upon that. But if I switch it to a different travel mode, let's say walking, this should bring back something different for a travel time. So right now we have like 13. So if I do that, I get back 52. So in this particular case now I'm using the travel mode and those collections of properties.
I have a question about the travel modes. Are they, I'm familiar with like the impedance attribute, minimizing on an impedance attribute. Is it exact equivalent, or is this an abstract little abstraction above that?
This is a collection of properties that includes the impedance attribute. So it's all the things that come together. Restrictions. What other things would be included in travel mode?
Different attribute names.
Yeah, there's a number of things that you can create. Any other questions?
Yeah, repeat the question.
Pardon me? Oh yeah, sorry. Let's see. So one other thing that we might as well look at, since we looked at creating a locator prior to this. I can use my locator that exists in this particular case. I'm using the one that's in the mobile map package, and I can use the suggestions that we created. And as I type into this text box, I can actually get back the values on my name field that adhere to the search criteria that I'm using. And then I can create, in this particular case, I just create field or points on the map based upon the geocoding. Or I could also use a service, and then in this case use and they're everywhere. And now I can figure out where the closest Starbucks are to the center of my map. To do this in code, I was just using I set up my suggestions. I have a suggestions parameter object that I pass into my suggest async method. And I use that based upon the input the user has. Later on, when I actually do the geocoding, let's see. When I do the actual geocoding later on, let me find it here. Yeah, sorry. When I do the geocoding later on, what I'm doing is actually passing in that suggestion result. I've taken it out of the list box that I created and then passed it in, because the geocode async accepts the suggestion object. You want to pass that in rather than say just the text that's in that suggestion, because the locator can use more information in that object to create a good result. So let's look a little bit more at some slides. So what are some related resources? Well, we have example apps out there. These are open source apps that built on the Runtime SDK, built by the Runtime teams, and they're an easy starting point to create your own application. We have a number of them out there that might be interesting to you. There's a mapping app that has search and geocoding, that's in Android. There's a nearby places, I think that's also an Android application. And just recently we released, last week I believe, something called an indoor routing app, and that's written in Xamarin. So I think it spans the iOS and Android space. If you don't have data, or you need to customize some data and you need some starting point, we have something called StreetMap Premium Custom Roads. What that is a file geodatabase in an ArcGIS Pro project where you can add in a custom feature class that's integrated into the network data set already, so that you can add your own roads to that and set up the network properties as you see fit. You can get more information at the URL, and there's a tutorial on how to do this at the URL also included on this page. And then finally, Navigator for ArcGIS. This is an app for Android and iOS. This is what our applications use when we're routing. We have something like Collector, doesn't have routing built into it. What it does is it calls out to the Navigator application using a URL scheme where it can pass stops or addresses to it, and then it can pass back control to the calling application once it's done. There's a whole bunch of examples on GitHub at the URL included there. For our road ahead, well, we have other routing solvers such as closest facilities that we're working on and service area. Online version, so hitting services will be an update 1, and hitting local data should be an update 2 of ArcGIS Runtime. We also have something called StreetMap Premium for Runtime. These are just pure MMPKs, so not the file geodatabase that you would have that I talked about for custom roads. They're for display, routing, geocoding, not for editing or adding, but they're at least data that you could use. They're actually the same ones that come within Navigator application, and is broken up into multiple regions that you can purchase. Take our survey and tell us how we did. And if you want the URL to that location, there it is. And I'm open for questions, comments, or anything.
There is a question.
Yes?
I have a question about when you have some sort of system that knows that you need to route from a particular edge, and you need to be able to tell it to do that, but that system only knows an ID and not even the object ID that it was built with. It doesn't know the edge ID. It just knows an ID, like a well-known ID to the system. It has to be actually looked up. So we have a solution for that. We have a server, we have an SOI that does work for us. We have to write it.
So,
then we get a fully specified network location.
so you have a location, or you have an ID of, what's the ID of?
Okay, the ID identifies a feature in the streets feature class from which the network data set was built.
Okay,
And so basically, I know that you either have to have a fully specified network location,
Yes.
or essential fields,
Yes, yes.
or it can take a lat long, and then it uses the NA locator agents to locate it on the network, right?
yes.
So this is like an additional one we have, which is specify a lat long and just an ID that identifies a feature, and then it does the lookup, gets the edge ID, and then fills in the for us, and then it passes it along. So is there anything like now, kind of, 'cause I did this development back in like 2.1. Is there anything new where that's like kind of automatically supported now?
Well,
So the question is there some sort of advanced way to specify stop locations, right?
Yeah.
Using some internal network ID identifiers or something like that. Yes, there is an API where you can set the network edge identifier and source identifiers, but that will require all information to be specified right now. So
that's
right
what
now,
he already did.
Yeah, right now we don't have a support where you can mix things, but yeah, it's a good feedback. If this is really required,
Yeah.
we can look into getting this case supported.
Sometimes it's also important to identify the routing from and to junctions as opposed to edges, because when you have one-way streets, we have a problem where it's doing it from a specific edge, then it actually won't go the correct way. It's actually got to be from the junction if it really is at the intersection. So that's another thing I was wondering if you had any direct support for saying, use the junction, don't use the edge for a particular feature, because it's known to be an intersection.
So the question is there a way to specify the stop from the junction location, essentially?
And in this case, we would want
yeah.
it to be specific, because it could be stacked with different logical levels. We want it to be from the junction at this logical level as opposed to this logical level.
Good question. I need to look at the API, but if we have source ID property for the network location,
Yeah.
I think it will first locate the location on the junction source. So essentially, yes, there should be a way to specify the location for that individual source.
But if they were stacked, it might arbitrarily pick one or the other. But that'd be the problem. It's just going off the lat long and the source ID.
Mm-hmm.
Right.
Right. Yeah, well, the point is when you specify your network location using the network fields, like source ID, edge ID, position along the edge, or, yeah, normally you don't use the geometry to locate that stop object.
But it seems like it's a binary choice. It's either use lat long or use fully specified.
Yeah.
Thank you.
Question.
Yes.
Was there an address field, when you geocoded those, was there an address field that you were using, or how did you get the stops on that?
You mean when I just created, from the little geocoder I created?
Yeah.
Yeah, I had just created a single field locator, and it had a single name field, so I was just typing that in.
There is a question.
Is there a plan to expose what API to create a mobile map package?
Oh.
So that we don't have to use ArcGIS Pro.
Not that I know of, no.
So that can be dynamically download from the mobile app rather than having to side load it.
Well, you don't have to sideload it. You can upload it to arcgis.com and then download it. So there's a way to upload it, and that's actually how Navigator works. They're all in a Navigator group, and the Navigator application can just pull it down from arcgis.com. So you don't actually have to sideload them all.
Okay. So I can look from portal.
Pardon me? Yeah. So you guys all excited to use our API?
Or
You
let's
are.
redo it.
So is this API part of like like the ACE Enterprise?
It's part of the runtime, ArcGIS Runtime, and it's part of the light license level, which I think is
It's free.
is free.
free.
Yeah.
Right, thank you.
Yes, you had a question back here?
Just a quick question. So in the Runtime SDK, you get hold of the network models by diving into the maps and then pulling an array of networks.
Yes,
of that.
yes.
But the located task is on the mobile map package
Yes.
itself. So it looks like there's only one.
You could
But I saw in the
Yeah, you can have multiple ones, but what happens in the background is it dynamically creates basically a composite locator. And so it's going to use the first one that it hits as the locator, or the first one you've entered as your first locator and such. It gives the most priority. Alternatively, you could create your own composite locator and just pass in that locator and it could use that too. There was arguments back and forth about how we should expose that or not.
okay.
Yes.
When you publish a solver, like a route solver, a closed facility solver, to a network using the old way with ArcMap, well, actually, that's the way you do it.
Yes, that's the only way to do
So
it.
the only way to do it now for the server, you have to have a map that you've already added the analysis layer to it,
Yes.
and then you publish it.
Yes.
So what I missed was when you create a mobile map package from ArcGIS Pro.
You don't need there is no analysis layer at that
you don't
point.
need the analysis
No.
layer.
No.
Okay.
Actually, I think if you have an analysis layer, you won't be able to package. It'll tell you to stop because it won't know what to do with it.
So all that you need is the network data. set.
Yes. So what you have there, and that's kind of why I pointed that out, is that when you're hitting a service, you have a few more properties because the layer has more properties, whereas the package, you're just hitting the network data set directly.
So you have to set all the properties.
You have to decide either within your API or how you just to expose those particular things.
The other way, when it's an analysis layer, they become the default.
Yes, exactly.
That you can override if you want.
Yes.
Okay.
So right now this URL is empty, that box folder, but tomorrow morning I'll drop all of these things in the data. The data is actually just the ArcGIS tutorial data, so I can share that in there. I'll put the PowerPoint slides in my project code.
Travel modes must have been added after 10.2 point something. I'm looking now. I've got ArcGIS.
Okay.
I said, how come I hadn't seen that?
Okay. Yes, there's something you want to use. We're definitely pushing them. All right. Thank you, guys.